And we are very fortunate today to have a very exciting and dynamic speaker in Dr. Frank Narducci. And he has been kind enough to speak at partnership programs on several occasions. For the few of you who may not know Dr. Narducci, he is a physicist for the Naval Air Systems Command.
So I'm going to tell you about what happened in 1905. Some of you who are science historians may recognize that year, but 1905 was called the miracle year, and I will tell you a little bit about 1905, Albert Einstein. I think some of you may have heard of him. Albert Einstein wrote 4 papers. Okay, that doesn't sound so much like anything that's that great. You guys probably write more papers than that in your English class. Okay, but he wrote 4 papers, any one of which could have won the Nobel Prize. So he wrote something about the photoelectric effect. I'm not going to tell you about that. He wrote a paper about Brownian motion, which I'm not going to tell you about, but 2 things that you might know a little bit about is special relativity and the mass energy equivalence. So everybody walks around from the time that they're in 2nd grade, quoting E equals mc squared. Nobody really knows what that means. So what about special relativity? So I said special relativity is what happens when you travel close to the speed of light. Well, Einstein used it to explain an experiment that was in existence at the time that nobody really understood. They had gotten some results, didn't make any sense, and he came along and explained it. With his explanation, he radically changed the laws of electricity and magnetism. And it was all based on the fact that the speed of light is constant regardless of the speed of the observer. And so the first thing I want to tell you is stop and think about that. Wait a minute. When you go home today and you're driving down 235 and there's a car in front of you going exactly the same speed as you, the relative speed of that car to you is 0. That car looks like it is traveling 0 miles per hour relative to you. Einstein came along and said, well, you know what? If you were moving close to the speed of light and that was a light beam in front of you, it still looks like it's moving at the speed of light. This is an absolutely crazy idea. This does not make sense. If we go out in the road, it doesn't look like that's what's going to happen when you travel at the speed of light. It turns out he was absolutely right. We have scientifically, experimentally proven that that was right. We did that a long time ago. Here's another crazy idea. I think it's in the 1920s, it wasn't the same year as 1905, he decided to add gravity to this whole mess. Okay, so now we've got this crazy idea that light is always constant no matter how you look at it. We add gravity into this picture, and all of a sudden, light, which has no mass, light has no weight, suddenly is affected by gravity. Okay, this is weird. So light can be affected by a gravitational pull of some kind. This is another crazy idea. Why would we expect light to be affected? In 1905 and 1920 was doing science because he thought about things that he was trying to explain that ultimately lead to absolutely critical corrections to something that we take for granted now every day. Like I said, I can't navigate my way anywhere without my GPS now. Okay.